Hello, hello, good evening. Good evening. Can you hear my voice? Is the voice is clear? Can someone comment over there? Is my voice is clear? Yeah, chalo. Okay, welcome, Nidhi Yadav, welcome. Yes, sir, audible. Very good. Chalo, welcome to Gate Academy. I am Sathish Kumar Durishetty, Faculty of Measurements. In the last class, we have discussed the TC bridges. Today, we will discuss AC bridges. The questions related to AC bridges. Okay, na? Questions related to AC bridges. Okay. So, sometimes the questions on AC bridges will be very simple, like theoretical questions. Sometimes he can ask you the questions somewhat descriptive type also. Descriptive type also. Okay. Chalo, let us start the questions. First, let us start with the match the following question. Yeah. Try to answer this question. Match the following. Is it visible, the question? Yeah. Try to answer. Yesterday I told you, yesterday I have given some hints. Okay, na? Yesterday I have given some hints. How to remember these bridges. Okay, so what is given? Self-inductance, capacitance, mutual inductance, frequency, Anderson, Wien-Robinson, Campbell, sharing. So these all are scientist names, but I told you how to remember. So can you answer this? Yeah, Learn Academy. Please share the class link to all your classmates, all your WhatsApp groups, Telegram groups, so that they can also come and join. Okay? Yeah. Answer this question. Hi Sundar. Good evening Shubham. Good evening. B, option B. Okay. See, I told you Anderson. First, let us start with frequency. So I told you frequency will go to Wien's bridge. Why? Because W means omega, omega means 2 pi f, f means frequency. Next, capacitance. Capacitance will go to sharing bridge. Capacitance will go to sharing bridge. Next, mutual inductance. So Campbell is for mutual inductance. Remember that Campbell is for mutual inductance. So Campbell will go for mutual inductance. And self-inductance by Anderson. Self-inductance by Anderson. So A goes to P, B goes to S, C goes to R, D goes to Q. So option B is the correct answer. Good evening Nivesh Kumar. Good evening. Good evening. Yeah, option B is the correct answer. Chalo, next question. We'll go for the next question. Yeah. So this question is multiple select questions. This question is multiple select questions. So try to answer this. Try to answer this. Is the question is visible? Yeah, I think all of you are familiar about multiple select questions. All of you are familiar about multiple select questions, right? Multiple select questions, MSQ, means there will be multiple options, multiple correct answers. So you have to tick all the correct answer. No audio na. Just a second. Hello, check, now it will be clear. Now it is audible. Once check it, now it will be audible. Yeah, so this is R, this is S, this is Q, this is P, and this is the galvanometer, this is the supply. Okay na? Okay, clear? So this is the supply. So here this R value 5 ohms, Q value 50 ohms, 10 ohms, 100 ohms. See, what is this bridge? If you observe, so this is the current. Okay na? So the current passing through P and Q. It is very trickily he placed. So you can convert this diagram like this. So this is one resistor, this is another resistor, this is another resistor, this is another resistor. So what he has done, suppose if you take this as between the R and Q, so if you take this as A, okay na? This as C, this as B, this as D. Okay, so this is the way he has kept A, B, C, D. So between B and C there is a voltage, and between A and D, between A and C there is a detector. Okay na? So this is the way you have to understand the diagram. Okay na? So this is the way you have to understand the diagram. So now if you see the current coming is going to be divided like this. So current going to be divided like this. So this is I1 and this is I1, okay, and so this is I2. So I is divided into two parts. So here comes up to this. So now what is asking? Figure shows a balanced Wheatstone bridge. If P is slightly increased, right now the bridge is balanced. 5 into 100, 500, 10 into 50, 500. So if P is slightly increased, then what happens? Current gets divided here. So this I1 has to divide into two parts. So I1 double dash, I1 dash. Yes or not? This current has to divide into two parts. Main current I is split into I1 and I2, and this is a junction, right? At this junction current is going to be divided into two parts. If this is increased, then current passing through here will be decreased and current passing through here will be increased. Okay. If P is slightly increased, the current in the galvanometer flows from C to A na. So this statement is correct. If P is slightly increased, when this resistance increases, this current decreases. When this current decreases, this current increases na? Yes, this current increases. So if P is slightly increased, the current in the galvanometer flows from C to A. Correct. Next, if P is slightly increased, the current in the galvanometer flows from A to C. Wrong. Why? Because when this is correct, it is wrong. Next one. If Q is slightly increased, so this is Q. If this Q is slightly increased, then what happens? This current will be decreasing. This current will be decreasing. This current will be increasing. Yes or not? So if Q is slightly increased, the current in the galvanometer flows from C to A. No. If Q is slightly increased, if this Q is slightly increased, the current in the galvanometer flows from C to A. If Q is slightly increased, the current in the galvanometer goes from A to C, which is correct. I think D is correct na? If Q is slightly increased, this is Q na. If Q is slightly increased, what happens? This current will be reduced. This current will be reduced. The current passing here will be reduced. Yes or not? So this current will be increased. This current will be increased na. So current passes through A to C na. Current goes from A to C or not? Flows from C to A or A to C? Please answer this question. I think A and C are correct. Once again check it. Once again check it. A and D are correct, right? if Q is slightly increased, see here, this is our I think A and D are correct, right? A and D. A and D are correct. Why? Because if Q is slightly increased, if this resistance increase, this current will decrease, na? So this current will increase. So A and D are correct. Subham. Nidhi Yadav, A and D. Pratik, A and C kaisa hota hai? A and D hota hai. Why? Because again check it. If Q is slightly increased, if Q is increased, this part of the current will be decreased. So this I1 part will be decreased and the E part of the current will be decreased. So if this is increasing means current will go to this side. So this part will be more, na? Current will go to A to C. Am I right? Yes, A and D. So this type of questions are multiple select questions, MSQ questions. Clarity aaya? Remember dear students, in multiple questions there is no partial credit. No partial credit. Keep that in mind. No partial credit. That means these two are the correct answers, but suppose if you give only one answer, suppose you are not given this as a correct answer, you are not going to get the marks. You are not going to get the marks. Chalo. Next question. Fatafat jayenge. Now let us go for this question. Try to answer this question. Figure shows a balanced AC bridge excited by a voltage source of fixed frequency. The impedance of the unknown arm Z is dash. So this is the unknown arm. So what is going to be the Z? A. So this is first arm, second arm, third arm, fourth arm. What is going to be Z? How to do this? Is the question is visible? So this is R. This is, let us take R1. Let us take this as R2 omega. This is L1. This is L1. This is Z. This is, let us take R4. Now question is, what is going to be the Z? Never do tomorrow. Yes, what you can do today. All of you try to answer this question. I am waiting for your answer. Figure shows a balanced AC bridge excited by a voltage source of fixed frequency. The impedance of the unknown arm Z is dash. How to do this problem? See, if you check this arm as Z1, Z4, Z2, Z3, so let us take this as 3, third arm. I can write bridge balance condition as Z1, Z4 is equal to Z2, Z3 na dear students. Whether it is a AC bridge or DC bridge, the basic condition is Z1, Z4 is equal to Z2, Z3 na. Okay na? See. Now what is Z1? That is R1. Z1 is nothing but R1. Am I right? Z1 is nothing but R1. R1, Z4 is nothing but R4. Z2 is this. Okay na? So that I can write as R2 plus J omega L1 into Z3. Z3 is Z. Z3 is Z. Let us take that Z. Let us take that Z as A plus JB. Okay. Let us take that Z as A plus JB so that it will be easy to solve. So that it will be easy to solve. Am I right? Let us take that as A plus JB. Okay. So now if you do multiplication, R1 R4 is equal to AR2 plus A J omega L1 plus JBR2 J into J minus omega L1 B1. Am I right? AR2 plus A J omega L1 plus JBR2 J into J J square minus omega L1 B. Okay, no confusion. Now, if I write this as this is R1 R4, let us write the parts of real. So let us write the parts of the real. So AR2 plus JBR2 so real part AR2 plus age omega L1 JBR2 plus J square, right. So if you take the real part, what we can write, AR2 minus omega L1B plus, if you take J common, that will be A omega L1 plus BR2. Okay. So if you equal these two, you are going to have the component of Z. This A and B will be balanced if and only if it is having some resistance component and inductance component or not. It should have some resistance component and inductance component or not. So what we can write, R and C in parallel, R and L in parallel, R and L in series, R and C in series. What is going to be the correct answer? So they are going to be, this part is 0 now, A omega L1 BRT is equal to 0. So from that you can write L1. Yes or no? So A omega L1 plus BR2 is equal to 0. Okay. Similarly, this one AR2 minus omega L1 is equal to R1 R4. If you solve that, this is not going to be correct. R and C in parallel can be cancelled. R and C series can be cancelled. Now R and L in series will be the answer or not? Am I right or not? Check it. A is going to be the correct answer. A is going to be the correct answer, R and L in series. Sir, to nullify inductor effect, capacitor should be in opposite arm. Shubham. Capacitor should be in opposite arm. So what is going to be the correct answer? Check it. What is going to be the correct answer? Option A, right? A, right? Option A or C? What you are getting? Option A or C? Are you getting option A or C? Sir, again, anglic radius should be used. Sir, B and C. B and C. How to do this? Or else we'll do one thing. One second. Yeah, this one, right? Or else we can say one thing. If you compare this as, okay, our standard bridge, Maxwell inductance capacitance bridge. Do you remember Maxwell inductance capacitance bridge? Maxwell inductance capacitance bridge. Like that we can compare, right? Maxwell inductance capacitance bridge. Actually, in Maxwell inductance capacitance bridge, this is our test branch. Okay, this is our test branch and these are the resistor. These are the resistor. And I think here we will be having a capacitor and a resistor, right? I think now this is correct. Is it clear? So this is what the Maxwell inductance capacitance bridge na. So R and C in parallel or not? So if you check the Maxwell inductance capacitance bridge circuit, you can get an idea. Yes, correct. So this is the Maxwell inductance capacitance bridge. Am I right? So this is our test branch. Actually, this is our test in Maxwell. This is our test. So this is our test, and to know that we are using this C4 and R4 na. Okay, so this is R1, this is L1, this is R2, this is R3. Am I right? I think now you got it. Just he has exchanged this here. This should be here and this should be here. You please take this here and this here. Now you'll get an idea. So R and C in parallel or not? Option C hoga. Just I was confused ho gaya. R and C in parallel hoga na? Yes or not, Nidhi Yadav? Yes, theta 1 plus theta 4 is equal to theta 2 plus theta 3. Correct. That's what we have taken, right? So if you take that Z, R and C in parallel, R and 1 by j omega C in parallel. Okay na? R and 1 by j omega C in parallel. So that is nothing but Maxwell inductance capacitance bridge. Clear? Option C hoga, B nahi. Option C hoga. Option C hoga, Maxwell inductance capacitance bridge. Clarity hai? Yes or no? Got it? Chalo. Now let us go for the next question. Yeah. Yeah, try to answer this question. Answer please. Visible? Question is visible? Yeah. Chalo. Sir, B is also correct. Practical capacitor series RC parallel RC. Please do quality factor based questions. Bonusly, we are going to get quality factor questions in Q meters. Okay, Q meters. Already I have given yesterday how the quality factor based upon the Calif factor, what are the bridges we are taking, Hayes bridge and all those things. Okay. Yeah. Now please answer this one. This is related to that only. How to do this question? A, B, C, D. The Maxwell bridge. This is a Maxwell bridge. The Maxwell's bridge as shown in below figure at balance condition. The parameters of inductive coil are dash. So this is an inductive coil. This is R1 plus j omega L1. This is R3. This is R2. This is R4 minus j omega C4. So which of the following is correct option? Try to solve. Sir, B is also correct. Practical capacitor series RC and parallel RC. But here in our bridges we are having R and C parallel na. In Maxwell inductance capacitance bridge we are going to measure the inductance of a coil with the known capacitance by varying the capacitance. Yeah. What is the answer for this? Of course, it looks lengthy, but generally in real part, kaise karna hai? So this is R1 plus j omega L1. Let me see. Bridge problem sometimes it may be look very lengthy, or sometimes it will be look very short. See, this is the same Maxwell inductance capacitance bridge na. So if you write this is test branch R1. And this is our R3 and this is our R2 and this is a parallel combination of R4 and C4. Am I right? This is a parallel combination of R4 and C4. Hayes bridge में RC series में होता है. Think IB also right, sir. but he should mention that actually, yeah, Nidhi Yadav, I understood your doubt, but actually in Maxwell inductance capacitance bridge C4 is variable. C4 is variable. Okay, C4 is variable. So what is here? Yeah, this one is R1, this one is R1, this is L1, this is R3, yeah, this is R2, this is R4, and this is 1 by j omega C4. Okay. So generally in bridge balance condition, these two must be balanced, right? So these two must be balanced. So Z1, Z4 must be equal to Z1, Z4 must be equal to Z2, Z3. Okay. So if you take that R1, R4 by, yeah, what is this? This is Z1, Z4, right? So what is the Z4? Z4 is nothing but parallel combination of this. So R4 in parallel with 1 by j omega C4, right? So R4 by j omega C4 by 1 plus R4 plus 1 by j omega C4, that gives R4 by 1 plus j omega C4 R4. So R4 by, so I can take directly like this, okay, by 1 plus j omega R4 C4, that's it. So Z2 is this R2 and Z3 is R3. So if you equal, the real parts will be equal, right? So if you compare the cross multiplication, if you do R1 R4 is equal to R2 R3 into 1 plus j omega R4 C4. So generally the bridge balance condition is achieved by comparing the real part. If you compare the real part, that's it. R1 R4 is equal to R2 R3. Unknown component is R1. Unknown component is R1 and L1. Leave it L1. R1 is what? R2 R3 by R4. Am I right? Now from elimination method you can solve it. Elimination method you can solve it, right? R2 R3 by R4. I think now what is going to be the correct answer? R4 by R2 R3? No, wrong. This can be eliminated. This also can be eliminated. This also can be eliminated. Then this is the correct answer now. Option A. Yes. Option A is the correct answer. Option A is the correct answer. No need to do all the things. L1, all those things no need to do. Just sometimes in the bridges you have to use the options. Otherwise it will take so much of time. Okay. Chalo. Next question. We'll go for the next question. Yeah. This is also match the following question. First try to answer this question first. Fatafat. What is the answer? Because one more questions. What is the answer? First, match list 1 with list 2 and select the correct answer. Low value of R, high Q inductor, low Q inductor, high voltage capacitors, sharing Maxwell. So फटाफट आंसर कर देंगे. कैसा करेंगे? I am expecting answer this time. Why? Because yesterday I have given the hints also. Yesterday I have given hints. Nivesh, Shubham. Yesterday I have given some hints to you. Answer please. Questions are, is it visible or not? Saunik Mukherjee, is it visible? Yeah. Tell me. Answer please. A, B, C, D. Which is the answer? Question is not visible. What? Yeah. Now it is visible, right? Yeah. What is the answer now? Low value of R, high Q inductor, low Q inductor, high voltage capacitor sharing Maxwell Kelvin. See, I told you resistance measurement, low value of R means Kelvin double bridge, right? So 1 A goes to 3. A goes to 3 na? A goes to 3. Next. Capacitors. Capacitors means directly we can go for sharing bridge. Sharing bridge. Next. Low high. Haze is there, haze. So high Q goes to haze. High Q goes to haze. Next. Medium actually, but he has given low. That means you can take Maxwell. Okay na? So A goes to 3. B goes to 4. So option D is a correct answer. Option D is a correct answer. Always remember like this. Haze for high Q factor. Okay na? High Q factor. Sharing for capacitors. Okay na? Maxwell for medium Q factor. Medium Q factor means of course it is low only, 1 to 10. Okay na? That's it. Okay. Anderson for Q less than 1. Less than 1. Okay. Clear? Chalo, let us go for the next question. What is the answer for this? The bridge circuit shown in the figure below. The bridge circuit shown in the figure below is used for the measurement of an unknown element Zx. See how to do this. This is unknown element, test element. Test element. The bridge circuit is best suited when Zx is dash. Low resistance, high resistance, low Q inductor, lossy capacitor. What is the answer? What is the answer? Low resistance, high resistance, low Q inductor, lossy capacitor. What is the answer? Visible? Question is visible? Very good, very good. See, actually, whenever these questions are asked, these are AC bridges, right? AC bridges. AC bridges means resistance can be cancelled. Why? Because we are not using the AC bridges for not for resistance measurement. If you observe this, this is what bridge? This is nothing but interchange. If you interchange, this is just what I was talking. This is the test. Actually, test will take as the first one. So test में क्या होता है? एक resistor and coil, and then comes a resistor. Then comes a resistor. If you see this is a parallel combination always. Parallel combination of this is for Maxwell inductance capacitance bridge na? Yes or no? Just he has interchanged. Just he has interchanged these two. Just he has interchanged these two. Okay. So this is our inductor. So Q, actually Q inductor. Lossy capacitors are for D-Schottky bridge, and this lossy capacitor will go for D-Schottky and sharing na? D-Schottky and sharing. That's why modified D-Schottky. This is modified D-Schottky. So by elimination method also you can do. All of your understanding? All of your understanding? By elimination method also we can do. Yes, Maxwell bridge. Please, if you are understanding, you can show me the thumbs. You can show me the thumbs. See, now I want to give one basic question like this. Try to answer this question. Actually, I am framing a question. This is one capacitor. This is another capacitor. This is one resistor. Resistor like this. Okay. So this is R. This is R. These two are capacitors. One is C plus delta C, other one is C minus delta C. Okay, C plus delta C and C minus delta C, and this is the AC supply voltage. This is the AC supply voltage. Okay, and this output plus minus, okay, is connected to a differential amplifier. Output is connected to a differential amplifier this differential gain is AD is equal to some 40, and this is the V naught. What is the expression for V naught? Can you do it? Yeah, I want the answer. Nidhi, what is the answer for this? What is the answer for this? Expression for V naught, this Vs is 20 sin omega t. 20 sin omega t. So what is the answer for V naught? Hello Rishikesh. Can you answer this question? These questions are actually combination of, this question is combination of measurements with the transducer. Measurements with the transducer. You can take these two capacitors as capacitive transducer. So this is capacitive transducer 1, this is capacitive transducer 2, push pull. Okay na? Capacitive transducer 1, capacitive transducer 2. So he has attached a DC bridge to this. So what is the answer? How to do it? All of you understood the question first of all? All of you understood the question? Need some time. Okay. Take time. Sonak Mukherjee, take some time. No problem. Do you understand the question first of all? I have connected a DC bridge, two capacitors. One is C plus delta C, other one is C minus delta C, connected to this, and delta C is plus or minus 5% of C. Delta C is plus or minus 5% of C. Then what is V naught? Need some time. Please all of you share these sessions to your friend circle, your groups, WhatsApp groups, Telegram channels. क्योंकि इतना efforts कर रहे हम, बहुत सारे efforts कर रहे GATE Academy since morning to evening continuous we are taking good set of classes. Okay, चलो कर देंगे. कैसा करना? Dear students, if you see this, first let us take the bridge. First let us solve the bridge. If you solve the bridge, कैसा आएगा? Two capacitors are like this, right? So if two capacitors are like this, and this is the resistor, okay na? Have you observed? DC bridge, two resistors equal, two capacitors are changing. So what I am doing, this is C plus delta C, this is C minus delta C. So this is the expression plus minus, right? He has given plus minus also over there. Yeah, plus minus. And I will take an expression first. This is supply voltage. V supply, this is ground. As this is op amp, generally, if you see here, this is a main current traveling like this. This main current gets divided here, I1, I2. Suppose if we consider ideal op amp characteristics, even though it is not mentioned, consider ideal op amp. Why? Because for ideal op amp, input impedance must be very, very high. Yes or not? Are you following? Please all of you show me the thumbs. I am waiting for your comments. Rishikesh, Sonak, Nidhi Yadav, Shubham, all of you following? All of you following? Just I have combined two different topics. So this ideal op amp, or you consider the general op amp input impedance is very, very high. Then what happens? This current gets divided, this current comes up to this. Ideal op amp means current passing through the op amp will be 0, na? Current cannot enter in this, current cannot enter in this. When current cannot enter in this, these two are in series. These two are in series, and I2 comes up to this, current passing here is equal to 0. Then these two resistors are in series. So that means I can apply the voltage division rule or not. So if you see, these two are in series. These two are in series. So this is R, this is R. Now I can take V bridge. I can take V bridge as V plus minus V minus. So what is V plus? That is nothing but voltage division rule across this terminal. If you take this node as A, this node as B, this node as C, this node as D, what is the voltage across this capacitor? Voltage across this capacitor, kaisa karna? Yes or no? Tell me yaar. If two capacitors are in series, this is C1, this is C2. What is the voltage drop across second capacitor V2? V2 is nothing but two capacitors are in series, same current is traveling I, okay na? So this is Z1, this is Z2, impedance is Z1. So V2 is equal to I into Z2. I is equal to V by Z1 plus Z2 into Z2. So Z is nothing but 1 by J omega C2. If you simplify, you are going to get opposite capacitance by total capacitance into supply. Am I right? If two resistors are in series, voltage across a particular resistor is equal to that resistance by total resistance. If two capacitors are in series, opposite capacitance by total capacitance, correct na? Now, these two capacitors are in series, I want the voltage drop across this. Voltage drop across this means opposite capacitance C plus delta C by total capacitance C plus delta C plus C minus delta C into supply voltage na. This is the beauty, this is the beautiful question. When you combine measurements with instrumentation, you can get beautiful questions. And now this is minus. These two resistors are in series, so R by 2R, R by 2R. All of you followed? Now this is C gets cancelled, delta C gets cancelled. Okay na? So this RR gets cancelled. So what I am going to get? What I am going to get? Vs into C plus delta C by 2C, C plus delta C by 2C minus 1 by 2. So if you simplify, I am going to get 4C, 2C plus 2 delta C minus 2C, 2C gets cancelled, Vs into delta C by 2C. All of you understood? So this is the bridge output voltage, dear students. समझ में आपको मजा आया? Very good. राहुल क्लियर, निधि क्लियर, चौहान क्लियर, सब लोगों को क्लैरिटी आ रहा है? सौमक मुखर्जी क्लियर? हाँ. Concepts Vs by 2 delta C by C. Okay. Now if you see the question directly, please remember, in the exam such type of bridges are given, directly try to remember the formula so that it will save your time. Now if you see the question, this particular bridge output is going to op amp na? So what is the op amp output, dear students? Op amp output V0, this is a differential amplifier. Op amp output V0 is nothing but AD into V plus minus V minus, V plus minus V minus na. So this is nothing but V bridge na. The V bridge is only connected as input to the op amp or not? Maza aa raha hai? So the output of this is connected input na. So V0 is equal to AD kitna diya? 40. AD kitna diya? 40 into V bridge. V bridge kitna diya? V bridge kitna diya beta? So this is 40 into Vs by 2 into delta C by C. Am I right? Delta C by C. Maza aa raha hai? Do you understand, Sonak? Delta C by C. Now you can answer 40 into Vs 20 sin omega t na. एक बार देखिए. If you take 20 sin omega t, 20 you can take magnitude 20, you can take 20 sin omega t, you can take by 2 into delta C by C. He has given delta C is plus or minus 0.5% of C, means from this you can write delta C by C is equal to plus or minus 5 by 100. So you can take delta C by C is equal to plus or minus 0.05. Okay, so if you substitute that here, you are going to get plus or minus 0.05. All of you understood? Now if you simplify, this will be 10. Simplify करो, एक बार simplify करो भैया जल्दी. कितना आ रहा है? Please simplify जल्दी. This will be 10, 5 by 100, 100 खत्म, 20 sin omega t आएगा. Yes or not? मजा आ रहा है? Same answer आया. This is 5 by 100, 100 खत्म, 5 4 जा 20. Correct? 20 sin omega t. Again the output is same. Plus or minus. Understood? Such type of questions, beautiful questions. See, we can frame such type of questions. बहुत सारा questions है ऐसा. See, for example, if you take this, और एक question मैं देना चाहता हूँ, और एक question. Try to do it. Nidhi, try to do it. These are the two voltages, E, C plus delta C, C minus delta C. This is a V0. This is the V0. This is negative terminal. This is a positive terminal. Question asked is, what is V0? What is V0? Try to answer. How to do it? Rahul, what you say? How to do this question? Yeah, these are some combinations of measurements with instrumentation. Measurements, instrumentation, analog. So these are the combinations. Measurements, analog plus instrumentation. Combinational questions. Measurements, analog and instrumentation. Yeah. See, what is this circuit? Can anybody tell? What is the circuit? This V naught is fed to this, na? This V naught is fed to this. Actually, sir, you solved this problem earlier. Okay, I solved. Okay, okay. So this is V naught. So this is V naught. Okay. If this is V naught, this is V naught, and this is V naught, this is V naught. This is V naught means this is V naught. So now with respect to this, we can apply the nodal analysis. With respect to this, we can apply the nodal analysis, right? So once again, this is the voltage follower, na? This is the voltage follower, buffer, voltage follower, V naught, V naught, V naught, V naught. So if you take this as C1, if you take this as C2, you can write the nodal analysis. If you apply the nodal analysis, V naught minus E by Z1 plus V naught minus of minus E by Z2 is equal to 0. Rahul, maybe it is repeated, but tell me the answer. V naught minus E, Z1 means 1 by j omega C1, when it goes to j omega C1, V naught plus E, j omega C2, j omega gets cancelled. Okay, yes or not? Push pull. Okay, push pull. Thank you. So what is the answer? V naught minus E, C1 is C plus delta C plus V naught plus E, C minus delta C. So if you solve, you are going to get V naught. I think V naught is delta C by C into E. That is the answer. Am I right? Chalo. Now we'll go for the next question. So these type of questions also you try to do, okay? We'll go for the next question. Yeah, try to answer this question. Question number 13 of your booklet. In the AC bridge circuit shown in the figure, this is a AC bridge shown in the figure, at balance the parameters of the coil. So always this is a test coil. So this is a test coil. You can take test coil. That is having some resistance and inductance. So test coil is having R and L. In the AC bridge circuit shown in the figure, at balance the parameters of the coil are calculated to be 50 millihenry and 20 ohms. So this is 20 ohms, 50 millihenry. Are you understanding? So when this is 20 ohms, 50 millihenry, this is 200, this is 5K and this is 50K and capacitor 0.5 microfarads. Okay, at balance, when it is balanced. Another coil is connected in parallel. Another coil is connected in parallel to the previous coil, and the balance is restored by changing R2 to 2.5K. R2 to 2.5K, the parameter of the new coil are then dash. Try to answer. Yeah. Try to answer. I am expecting. Is the question is visible to you, Nidhi, Chauhan, Rahul Jaiswal? Is the question is visible to you? Is the question is visible to you? Z1 is a coil. The coil self-inductance is given as R as 20 ohms, test coil self-inductance as 50 millihenry. Okay, na? So this is a test coil. This is our R1, this is L1. So this is 20 ohms and 50 millihenry. And R2 is 200 ohms and this R2 is 5 kilo ohms. So this is R2, this is R3, and here we are having R4 and capacitor C4, R4 like this. Now the bridge is balanced for these values. The bridge is balanced for these values. Okay na? Listen carefully. How to understand this question? Do engineers opt in the chat box? Yeah. So how to do? Any idea? See here, this bridge is balanced, right? Bridge is balanced means what is the condition? Z1, Z4 must be equal to Z2, Z3. Think logically, Z1, Z4 must be equal to Z2, Z3. Z1 is what? R1 plus J omega L1. Yes or not? R1 plus J omega L1. Z4 is what? Parallel combination of this. R4 parallel combination of 1 by J omega C4. That will become R4 by 1 plus J omega C4 R4 is equal to Z2 is nothing but R2 R3. R2 R3. Okay na? Or else I will do like this. This is Z1, Z4, Z2, Z3. Bridge is balanced. Bridge is balanced or not? Amab Chakrabarati. Bridge is balanced na? Now what he is doing? He is not changing any other parameters. He is just making this as by 2. Am I right? He is making this as just by 2. एक बार check कर दीजिए इधर क्या हो रहा है? In AC bridge circuit, it balance the parameters of the coil are calculated to be 50 millihenry and 20 ohms. So now what he has done? Initially as a balance hai. Now he has kept another coil. He has kept another coil here in parallel. He has kept another coil in parallel. That means there is a coil in parallel. We don't know these values. We don't know these values. So these are Rx and Lx. All of your understanding. All of your understanding. Initially for R1, L1, R3, R2 and R4, C4 bridge balance ho gaya. Now what he is doing? He is keeping this. Then bridge becomes unbalanced. Please answer my question. Please answer my question. Please answer my question. This is R1, L1, this is R3, this is R2, this is R4, C4, bridge balanced. Now what he is doing, he has kept one more parallel element, then bridge becomes unbalanced. When bridge becomes unbalanced, another coil is connected in parallel to the previous coil and then unbalanced हो गया. वो balance को restore करने के लिए R2 has become 2.5 kilo ohms. That means what? Previously जो कुछ है इसमें Z2 is nothing but R2 उसको off कर दिया. उसको ऑफ कर दिया. That means he is not changing Z3, he is not changing Z4. Am I right? Z3 is unchanged, Z4 is unchanged. Now Z1 has to become how much? Z1 has to become how much? Yes or not? To get balanced, Z1 has to become how much? Please answer my question. Initially Z1, Z4 is equal to Z2, Z3. Then along with the Z1 he has kept a parallel circuit. Then bridge becomes unbalanced. Unbalanced हुआ bridge को balance करने के लिए Z2 को half कर दिया without affecting Z3, Z4. Now if you want to achieve balance, what should be this Z1? The new Z1. This was the old. Dear student, this was the old. Now this is the new. So this is balance. This is balance. Okay na? Now again this also has to be balanced. This also has to be balanced means this should be by 2 na? Logical question or not? Sir, this is not the official G group. What Rani Kumari? What you are asking? Yes, becomes 1 by 2. So Z1, new Z1, very good. New Z1. So new Z1 is equal to old Z1 by 2. Old Z1 क्या है? Old Z1 क्या है? Old Z1 क्या है? This one. old 50 millihenry by 20 ohms. So when it will become by 2, that means again in parallel the same as it is should be connected na. So if suppose you understand this logic, if two components are in parallel, so this is Z1, now this Z1 has to become Z1 by 2, means what? The as it is same component should be in parallel na, as it is same component should be parallel na, yes or no? That means what? New Z1 is equal to old Z1 by 2, that's it. Old Z1 by 2 होना चाहिए, old Z1 by 2 होना चाहिए means उसको क्या attach करना है? As it is the same element should be attached or not? So old Z1 by 2 करने के लिए, so the new component also should be same na? So it should be same as it is or not? So if this is 50 millihenry, this is 50 millihenry and 20 ohms, then this also should be 20 ohms and 50 millihenry na? Done. So what is the answer? Answer is B. Maza aaya? Yes or no? All of you understood? Then this particular opposite parallel inductor also should be same. That means if you keep the same inductor, then it will be Z1 by 2. Very good. 20 ohms and 50 milli. Option B. Correct, right? All of you got the clarity? All of you understood? Good question or not? Conceptual question or not? No need to solve. Z1, Z4 is equal to Z2, Z3 balanced. Then फिर balance Z2 by 2 कर से okay. Thank you. Chalo, now let us go for the next question. It's a very simple question. This was asked. Many times asked question. This is many times asked question. Everybody can answer. Kelvin double bridge is best suited for measurement of. In IES prelims paper, many times this question was asked. Many times. What is the answer? Kelvin double bridge is best suitable for the measurements of inductance, capacitance, low resistance, high resistance. Megger, I've heard this word, Megger is used for, I'm asking Megger. Kelvin for low resistance, Megger for? Any idea? Very good. Megger is for high resistance. Please remember all these things. Megger is for high resistance. Okay, na? High resistance. Megger is used to what? To test the insulators. Megger is used to test the insulators. These are important objective bits, important objective questions. अगर आपने कोई इलेक्ट्रिसिटी बोर्ड का पेपर लिख रहे हैं, ये क्वेश्चन बार बार आता है. Important objective questions. ओके ना? चलो. Now. Try to answer this. एक second. Question number 14. Fast. It's not repeated question, it is a different question. The resistance and inductance of an inductive coil are measured using an AC bridge as shown in the figure. The bridge is to be balanced by varying the impedance Z2. The variable component is Z2. So, for obtaining Z2 should be consist of element dash, R and C, R and L, L and C, only C. Can you answer? Can you answer this? So don't confuse, directly you can go with this. This is the main current, this is the I1, this is the I2. So here current passing is 0. So these two are in series, these two are in series. And product of opposite terms must be balanced. R1 Z2 must be equal to R3 Z3. So this is Z4. Am I right? Opposite terms are these two now. Are you understanding or not? Any confusion? Any confusion, dear students? If you want, you can take like this. This is our R1. This is our coil. Okay. And this is our, yes, just change the terminals. Yes, just change the terminals. So this is our supply. This is our supply. Am I right? So this is the main current. So this is R1 and these two are in series. Okay na? Please don't confuse about the notations. Whatever the notations he has given, we follow that. This is R4, this is L4, this is R3. So this is Z2. The Z2 is variable. So what is the concept? Z1, Z2 must be equal to Z3, Z4 here. That means R1 into Z2 must be equal to R3 into Z4. Z4 is nothing but R4 plus J omega L4. Am I right? J omega L4. Let us take Z2 is also, as he is mentioning this, let us take Z2 as A plus JB format. Now I think you can get it. Z2 you can take it as A plus JB format. A plus JB, that is R3 R4 plus J omega L4 R3. Am I right? Simple na? So you can write A R1 JB R1 is equal to R3 R4 plus J omega L4 R3. Simple. If you equate real parts, A R1 is equal to R3 R4. That means A, we want A na? A must be a resistor. A must be a resistor, clear? A must be a resistor, clear? Next, if we equate these two, JB R1 is equal to J omega L4 R3. JJ gets cancelled. So what you are going to get? What you are going to get? Jaldi fatapat boliye. So B is equal to omega L4 R3 by R1. This is the resistor. So B is equal to omega LR. That means what? A plus JB means this should be a resistor. This should be an inductor. Am I right? So what is the answer? RC? No, 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 no. Check it. Check it. R and resistance. R and L. Dear students, don't confuse about the notation. This is Z1, this is Z2, this is Z3, this is Z4. Variable component. Variable component. Yes or not? R and L. Nidhi, R and L. Yeah. Don't confuse. Please don't compare with your answers. Okay. Don't compare with your bridges. Sometimes you have to go through this diagram. In the diagram, the variable component is Z2. By varying the Z2 is making that. All of you got the clarity now? Yes or not? Option B is the correct answer. Option B is the correct answer. Got it? Clear? Chalo. Yeah, try to answer this question. Sorry. The answer. Maybe either C, I think the C is the correct answer, take the derivation. But this type of questions actually came in the earlies, not in the recent exams, very descriptive model. Okay. Chalo. Thank you very much, Rahul. So, yes, really it is a selfless service. They are doing many questions in free classes. In free classes, we are doing the valid content. We are not doing any marketing content. We are giving the valid content. So, please like it, share it, subscribe it and share to maximum people so that maximum people can be benefited. Okay na? So, बहुत सारा questions है आने वाला chapters में, बहुत सारा questions discuss करना है. अभी तो bridges खत्म हो गया, almost bridges we have done. So, in the next coming chapters, we'll solve all these PMMC questions, measuring instruments questions. Okay, many questions are there. Almost we're having almost I'm going to get 91 questions. 91 questions I am going to discuss. Almost 91 questions. Around 91 questions we are going to discuss. 90 to 100 questions we are going to discuss. All are PYQs. All are PYQs. So please remember that. Please solve that question and tell me answer tomorrow. Okay. Chalo, Tata, take care. Bye bye. Jai Hind.